time, so thank you to the Ekoparty crew for bringing me here. It's a pleasure to be in Argentina. Thank you for being here so early in the morning, and thank you to the beautiful girls for making the speech so much more fun, because I can see you watching the huge black guy with a beautiful girl's voice. That's cool. Okay, so a little about me, more than you ever want to know. I'm Claudio Kirschbaum. During the day, I work as a pen tester in a small Italian company, Secure Network. I'm the principal pen tester there. During the night, I get my PhD. I'm the first Italian executive PhD, whatever that means. And I'm also an editor on security for virtualization.info, one of the most influential blogs on the map. So, as you might have guessed, and as Leonardo said, I'm from Italy, a country you most likely know for our wonderful pizza, for our very, very well-organized mafia, and for our great soccer team. But yeah, that was pretty cool. Okay, so for our crappy soccer team. Okay, so yeah, thank you. Back on track. So why I'm going to speak about virtualization security, or even better, virtualization pen testing. Well, because I feel that there is definite need for security in the field. More or less, everyone is going to virtualize its own servers. Everyone and their mothers is virtualizing today. But I feel that we are maybe running a little bit too fast to be really effective. And maybe we are really forgetting about security while we try to build new and new solutions on virtualization. I guess you all know about virtualization by now. It's 2010. Who has never used virtualization here? Okay, that's more or less what I was expecting. Okay, fine. Thank you. I'll tell you later. I'll tell you about Facebook as well. But so the point is that we really need security in virtualization environment, because from a pen testing perspective, virtualization is really interesting. Because if you can manage to break the virtualization stack, then it really means a lot of stuff. If you break virtualization, it means that you can add the underlying layer. You can have what's under the machines, the virtual machines. So it means that you will most likely be able to access the systems locally through the virtual console. And as we all know, if we can manage to get physical access to a server, then we just own it. And that's more or less the same that happens if you can manage to break the virtualization environment. It also means that you are most likely bypassing all those nice firewalls that you bought, all those nice access control systems, because you're basically accessing directly the virtualized system. So it's really interesting to break the stuff. And you're also hitting multiple targets at once. You own a virtualization server, a virtualization host, and you get all the virtual machines in a very nice box with a tie on top of that. So it's also very likely that you will be able to find all vulnerability. Why is that? Well, just think about your virtualization host system. You have this very nice host system which is running, 20 virtual machines. And now the security guy comes to you, the IT manager comes to you and says, we should really update the host system, so you just have to move those 20 virtual machines somewhere else, we can upgrade the server, reboot the stuff, it's not going to happen. There are virtualization patching solutions which are very nice and work. However, I don't really see them a lot in the wild. We've done, really a lot of virtualization-based penetration testing, and we consistently find outdated host systems. So it's a lot of fun, as we will see. What's more, a lot of the Fortune 1000 companies are using virtualization, so you're bound to find it in one form or the other, more or less everywhere. What's even better, that's yet another form of find the vulnerability once, exploit forever. Because you really have a small number of solutions actually deployed. I can name maybe 3, which are the most important ones, VMware, Zen, and Hyper-V now. That's more or less what you find around. So, I don't know about you, but this kind of scenario is more or less my personal heaven. Okay? So when I think about heaven, I think about taking virtualization, because you get everything. If you don't know what this guy is, please do convert yourself to the Flying Spaghetti Monster religion. But before we go on, I have to make clear something. In this talk, I'm going to speak about virtualization pen testing. and VMware Pentesting in particular. Which means, let's face the elephant in the room before we go forward. I'm not speaking about escaping the VM. Because, yeah, it can be done. It can be really cool. We've seen yesterday yet another way to get outside the crappy virtual PC software. Yeah, it will be due an exploit. It's not very likely that it will be some kind of design or infrastructure stuff, most likely a very specific exploit. It can be bad, so the vendor, hopefully at some point in the future, will release a patch for whatever you find it. And yeah, for sure it will happen again. However, it's not something that you can really easily audit during a pen test. I mean, escaping from the VM is something very specific, which is not going to happen every day during your work. So what we are going to do is something which is easier, so I like it, and something which you can actually use during a penetration test. So we're going to attack the infrastructure, the virtualization infrastructure. So that's what we are going to do. Okay, how do we do that? Well, we need some tools. So the first problem I had was, okay, I'm starting to see, I don't know about you, but during my pen test, I became at a certain point, like a couple of years ago, I began seeing a lot of ESX, VMware-based solution in my targets. And I was just looking at them and say, okay, what now? Metasploit is not telling me anything, Nessus got no clue, and all the other tools are just, yeah, it's a server. Yeah, I know that, but what can we do? So I started looking for tools to do the stuff, and I found more or less nothing. Okay, that's me looking for the tools. So there was more or less nothing. So what I did was obviously, you do your own, because we are hackers, so we like to do our own stuff. So I started coding, with the help of some fellow hackers, my own hacking tool. The tool that we are going to see today is called Basto, not Basto, Basto. And it's the Virtualization Assessment Toolkit. Basto, by the way, is a very nice city in the middle of nowhere in Italy, so if you ever happen to pass by, just skip and get to the next one. It is basically an exploit pack for Metasploit. So there was Metasploit around. It was kind of interesting to learn Ruby while coding, so the code will be very crappy, but I learned Ruby. And basically, it's focusing on virtualization and cloud security. There are other exploits, not just VMware, but we are going to see those. Today, you can already download the version Beta 03, so you can just download it and use it. It's for free. However, it's under a feedbackware license, so if you use it, you're bound to give me some kind of feedback. Those are the fellow hackers who helped me code Basto, so thanks to them. That's the tool we are going to show you today. Before we go forward, let's make sure that everyone is positive on what VMware is and more or less what the components are. So let's see an archived zipped version of VMware. VMware basically has got two main branches of solutions. On one side, you've got the desktop stuff. The desktop stuff, yeah, it's cool, but it's not very interesting during pen testing for now. Personally, I don't really like client-side exploits, because yeah, with cross-site scripting, I can know your box, but that's not what my customers are paying for at least for now. So we have the server products. On the server products, you have two main brands, which are, product lines, which are the ESX server and the ESXi server, which is now called hypervisor for whatever reason. That's what we call the hypervisor layer. Those are the actual software running the virtual machine. They are standalone operating systems, Linux-based, but more or less very customized. Okay? And those are your two main targets. But then, you also have the management node. A management node is the virtual center, or vCenter. The vCenter is basically a management console, which is software which runs on top of Windows or any Windows server, and can be used to manage the ESX and ESXi systems. So it's very interesting to attack because it's Windows-based, so we know more or less how to deal with that. And if you own that, you own the VMware systems. And then you have the client, which is a binary software running on Windows and possibly iPad. I heard that they did an iPad client before doing the Linux client, so I actually hate them. And that's the client which you have to use to manage the infrastructure. That's all the stuff that we are going to deal with. Okay, so enough introduction. Let's get down to how I actually break this stuff. So when I started researching on this topic, I needed a plan. So this was more or less my plan. So I needed a very easy plan because there is the OWASP testing guide, and I wanted more or less something similar for virtualization. However, it takes a lot of time to write an actual exploiting plan. So I kept it very, very simple. So my plan reads more or less like we go type and pound. Okay, more or less. So those are the steps I've taken. Let's start with the first one, recon. That's a core part of your pen test, because if you don't know what you're dealing with, then you definitely cannot pen test it. So the first question to answer is, how do you notice that it's virtual? Well, there are basically two answers. The first one, we're not really interested in it. It's if you're locally, so are you in a VM, there are two main ways. There is the easy way. The easy way is look for the MAC address. That's what Metasploit is doing, for instance. Or look for running VMware tools instances. It's quite easy. Then there is the hard way, which means do the red pill, go the red pill way, so assess the hardware. I learned yesterday that there is another interesting way to do that using memory assess. But so there are various ways to do that. However, that's not really interesting in a pen test. I'm by far more interested in doing that remotely. So identify the virtualization infrastructure remotely through the network. So basically, this means fingerprinting network services. So being able to actually identify the VMware server running through the network services, which is also helpful to identify hidden virtualization stash. What I see consistently in all my penetration tests is that developers tend to use virtualization in servers hidden behind their desktop, just to run a testing machine. And you can have all sorts of fun. You can manage to identify that and attack that, because you find old code and debugging code, all this sort of stuff. So I was interested in identifying this. So what I did, I wrote a module of Vasto, which is called VMware version, standard Metasploit naming. Basically, you leverage a SOAP API call. More or less all VMware products dialog through a SOAP interface through HTTPS. So what you have to do is quite trivial. You just perform a SOAP API call on, well, just two ports, 433, yeah, the standard HTTPS port, and 83333 port. So it's quite easy. You just connect to the port, perform the SOAP API call, and you get a very nice package of information with the exact version, the patch level, the API version, and all you need. So that's more or less what the VMware version software does. It is an auxiliary module in VMware, so it leverages all the standard features of Metasploit, and you can just run it on an EP range or whatever. So just to give you an idea of how Vasto works, I'll show you a very quick demo of VMware version. It's nothing groundbreaking, but it will show you how it works. So, what's it going to say? Yeah, nothing at all. So, let's move to the video. Okay, there it is. So, this is, it is standard Metasploit. It's a standard Metasploit window. So what we are going to do is simply load the Vasto module, VMware version, and see some information. As you will see, the only required information are the remote host and the port that you want to use. So what we are going to do is just fingerprint a couple of services. So we just configure the host to an SX host, launch the exploit, and as you can see, maybe, can you see it? You get the exact version of VMware ESX server back to the build level, which more or less means the patch level that you're running in. And you can do the same for a lot of other products from VMware, like an SXI server. You get, once again, the exact version, because we're the exact same version. Or a VMware converter, which is a completely different product, yet has the very same interface. So you can just query and get the exact version. It more or less works for anything that I've seen until now. There is actually another way to do that. There is an XML file which you can retrieve to HTTPS, which will give you the version, but I mean, it's far more cool to use a SOAP API call than to just download the file. So, this is how Vasto works in a very nutshell. Let's go forward and see, once we go to the version, what we can do. So, what I needed now, once I identified the version of VMware running on all the VMware servers, What they needed was sort of an attack plan to actually be able to get inside VMware systems. So I developed these multi-layered attacks. Okay, I like to think about that as a pie, because as you can easily guess, I love dishes. And this is the path I use it. Basically, I start by attacking the client, because I feel that's very interesting stuff, and everyone is doing that, and if it's easy, why not? And then I will attack the hypervisor servers, so the core servers running the virtualization stuff. Then I will go to attack the support infrastructure, the management infrastructure, and then do some cool stuff with some internal modules. We'll see that. So let's start with the first one. The first one is attacking the client. Yeah, if you plug the... Okay. The first one is attacking the client. How do we attack the client? Well, let's begin by stating what the client is. So, in the beginning, we had all command line-based tools. Okay? Then everyone moved to these very cool web applications, and then we got back to the binary clients. So, you might know that VMware has indeed a web interface we will access as well, but they are going to dismiss that. So what we have to go with is a binary client, which is more or less the standard in all virtualization solutions. So let's see how we can actually attack the VI client, which is the binary client running it. In order to understand that, we have to go through the update procedure. Why? Well, because the update procedures is an auto-update feature which happens just before you log in into a VMware server. So what basically happens when you press the login button in your VI client is that the client, for whatever reason, asks the server for an XML file. That goes this clients.xml file, which the server provides. Then there are a couple of other calls to get the server instance, the server status before the login. Then once again the client asks for the client's XML file, don't ask why, no clue, and then there is the login procedure. Okay? This is the procedure we're facing. So, as you might have guessed, the interesting part here is that XML file. Let's see what's inside the clients.xml. Well, there's actually a very simple XML file with an out port, a version number, this is the server providing the client with this information, and a download URL. Well, since you're all hackers or security professionals, you already guessed where I'm heading to. If you can manage somehow to change that patch version, you can even control the download URL to have the client grab whatever file you want. If you're very cool, you can also do stuff like SMB relay or this stuff, but we are going the easy way. So, just looking at this, what I did was I coded a tool which is capable of intercepting the connection, changing these values, and just drop an exploit to the client, owning the administrator. If I own your administrator, then I'm fine with that. I don't really need to break inside your infrastructure. And that's exactly what the VMware VI Larker module does. There is a catch, however, this is running over SSL, okay? So, the point is that the administrator will get a pop-up, huge pop-up saying this is an invalid SSL certificate. But since you're facing a Windows administrator, it will be busy reading Cem Alonso's blog, so we just click, okay, go. This is more or less what I see happening every time. So every time I did that, I just take it the administrator. The point is that we face people not using trusted certificates, so they're used to have this pop-up because the certificate is not trusted anyway, and there is no code signing, absolutely, on the updates. So you just will get a warning and you're on it. As bonus info, old version of the VMware clients did not check for valid SSL certificate, so it's even more fun because they didn't even check. Okay, let's see the VI Larker module working. This has been recorded. It's not 0 day, but VMware, let's say they're having some issues fetching that. Okay, so it's, they say that the SSL pop-up is enough to protect the administrators. You can agree, you cannot agree as you wish, but that's the state that they're at. So let's say the VI Larker module working. This is, once again, example of Vasto. On the right side, you have the user. That is the VI client. I'm running that on the same screen so we don't get mad switching on stuff, but I was running the VI client inside the VMware workstation machine, so it gets even more complex. But on this left side, you have the attacker with Vasto. So you have to be able to perform man in the middle. So it's back in the 90s again, ARP spoofing and all this stuff, which, in my opinion, works pretty well. So what we do, we just load the Vasto modules, which is the BI lurker. As you can see, maybe, can you see that? It accepts any standard Metasploit payload. You can load any kind of payload. It will ask for all the standard information, like remote host, remote port, and all this stuff. So what we are doing this time is, well, we are just enabling SSL and setting the local port, and that's it. Then we launch the exploit. Now, the iLarker will open a local server, so you have to run that as root because I'm using the 443 port. And we will wait for the client to connect. So this is the administrator. We use a random username and password because it's not checked. And we connect to the remote server. So what we are going to see is, as you can see, the SSL warning certificate. So it's there. However, remember that's standard stuff. So the administrator ignores, and that's the helpful pop-up, which it gets. Okay, so it's run this over, save this over, whatever it is, wherever it comes from. So obviously the administrator will just say, fuck, they have updated the server once again, and we'll run this over. And we can see on the other side, it's still reading Chemalonso stuff. So on the other side, we get the Meterpreter, bind TCP payload being loaded, and here it is. It has been downloaded, temporarily saved, and run. Now I'm using a very lame payload, so you will see also a pop-up from the Windows firewall, but I'm sure that you can do better. Provided I can make the video restore. Okay. So we get a pop-up from Windows, and we just say, okay, yeah, whatever. And the other side now, what we have to do is simply using the Meterpreter, the auxiliary module, which can be using the multi-handler to connect to the Meterpreter shell, set the payload, set the remote host. Can you see that, or it's too small? Fine? Okay. We launch the exploit, we launch the session, and it's game over. Okay? And we just own it, the administrator. Thank you. So, that was the easy part. Okay? This is something which you might be able to do during a pen test, but not that often, not as often as I'd like. So, let's leave the BI larker behind, and let's move to the next attack path. The next attack path is attacking the hypervisor directly. We're going quickly through this part because I know that there are a lot of attacks which are being patched at the moment, but there is one very famous attack which was disclosed last year, and we are going to see that. In my opinion, that's the most direct hit that you can do to the virtualization infrastructure, and it really hurts. This attack was revealed, was discovered by Flick and Morehouse, and was released last year. So what I did is I took their exploit, which was impaired. Remember, I don't know about you, but I don't like having 1 gazillion tools all around to do the stuff. I like to have one tool which is able to do more or less all that I need. So I took their exploit, imported that to Vasto and Metasploit accordingly. So credits to them. You can just download and use that on Vasto and Metasploit. What you can basically do is you can retrieve any file as the root user as long as you can connect to the remote ESX server. It's a basic fast traversal attack as the root user, you know, the usual stuff. And it works more or less on outdated, before the end of the year, ESXi server. And VMware server, which is a free product that you should not be using anyway. I know Mariano is, bad move. This attack, however, was well known, and we're not going to cover it anymore. So let's just forget for a moment about that, and let's move to another attack. So credits to them, but you know it's in Vasto, you can use that, but it's a little bit old, so let's not get through that. The next one is the one I prefer, because it's attacking the supporting infrastructure. I don't know about you, but when I do pen test, I really love to go through sideways attacks, like owning a printer or this kind of attacks. So attacking the supporting infrastructure is what I prefer, because it gets you a lot of feedback, a lot of nice stuff. You get a lot of nice stuff out of it. So, for the supporting infrastructure attacks, let me introduce you my little friend. My little friend is a deadly one, and it's the ONAB. You see, that's a deadly machine. It's got a weapon as big as half of it, okay? So it's a huge weapon, and it's literally a killer. Do you know how many people those little things kill every year? No clue? I'll tell you, obviously. 23 for a year in the US. That's deadly. That's more than sharks, actually. That's more than all the snakes, all the species of snakes together per year. By the way, that's my country, no? Italy, okay. That's San Domenico dei Serpari. That's basically a party in Italy where serpent tamers from all over the world join in a small, meaningless town in Italy, and they just throw snakes on the statues of saints. I don't know what it means, but that's what it is. That's what it is. Very nice place. If you're skipping Vasto, drop a... Okay, so this is very interesting because this is how a small bug can actually kill you, can actually hurt you. So this is the story of an interesting bug I found. Well, no, it's not that I found. It was a very well-known bug, but it was in another context. So I basically just recognized that VMware was affected as well. This bug is a path traversal bug. It's a path traversal vulnerability, so it's actually not like rocket science in the update manager. So I'm going to show you a module which is called a VMware Update Manager Traversal. It is actually an old vulnerability. It is a Jetty version, an outdated Jetty version. I guess we are more like on version 22 or something like that, which was included in VMware. And actually, really a lot of products that are using old versions of Jetty because they don't really care about upgrading. This service is the service in charge for deploying security updates on the ESX servers. Ironic, right? This version is vulnerable to a path traversal. It is running as system by default, so it is a system level path traversal on the Windows server where the vCenter is running, more or less always. What you need to know is just a magic string to get the path traversal going. That's more or less the only information you need. By the way, I requested the Jetty team for a proof of concept because it was released, it was patched like years ago, and they said like, yeah, we can help you, sure, just tell me how many consulting days you need. I mean, a POC. So, here is the POC for free. Here is the magic string. It's actually quite trivial. You just have to encode the question mark and drop a lot of dots afterwards. Easy. So, I had this path traversal as a system on the vCenter server. And I was like, yatta! I did it! I got it. No. Okay, no. It didn't work. Why? Let me ask you. You have a path traversal as system on a Windows server. How do you own the box? How do you do that? Are there pen testers in root? Okay. What I tried to do was I read the SAM file, SAM file. It didn't work because there was an outdated password in it. So during the pen test where I discovered that, I was not able to break in through that. However, there is a catch. So follow me, because it is something weird which only happens in VMware, what we are going to see. What I did is I tried to read all the files which were written by the vCenter host. Can you hear me? Okay. With the vCenter host. I started reading through them and looking for something interesting. And what I found is that for some reason, which I guess they don't know as well, inside one of the not documented log files of VMware, you get this very interesting information, which is the SOAP session ID of the currently logged on user. For you to grab, just go and get it. And by the way, the file is readable by any user of the system. So basically, if you have any level of access to a vCenter host, you can just own the box by reading the currently logged on user sessions. The only catch is that that file is written every 5 minutes. So while I was preparing the demos for this tool, I couldn't have the exploit working because I was like logging in and checking the file, logging in, it's not there, it's not working anymore. No, you just have to wait 5 minutes. That's why I got videos, because otherwise it would take a lot. So there is a lot of interesting stuff here, but what we are going to do is we are going to use the SOAP session ID. So I get the SOAP session ID, which is the currently logged on session user session. And I say, cool, now I did it this time. No way. Because you're still working with a binary client. So you can't just, plug in the session and hope it works. I mean, this is the login console. What do you do with that? Where do you use the session ID stuff? So what I did was, like my old grandfather said, I did like the monkey. And as you know, monkeys write session. And so I built this VMware session writer. Basically, it's quite easy stuff. It's just a proxy which emulates the dialogue between the server and the client, faking a login because you don't have any login information. Even with your session ID, you won't get in, so you have to emulate the login phase, the login procedure. And once it has performed the login, it will just plug the session ID inside the session and let you get in as any user you want. So this is a module which you can use as a local proxy to inject the session ID you just stolen. However, I had to use two different modules. First to download the stuff, then to plug it inside the session writer. It was boring. I like one-click Pwned tools. So what I did is I built the VMware Auto-Pwn tool. The VMware Auto-Pwn tool will just combine these two things and let you get in with a double click. So let's see it working. Okay, so this is our target, a vSphere 4.0, but it works anyway with the latest version, which is 4.1. What we do is we wait until the administrator logins. It is actually not needed because there is a needed hidden user inside VMware, which is called the virtual center user, which logs in periodically, so you can just get its session. So this is the administrator logging in and doing his stuff, working, do whatever they do, like reading blogs. And in the meantime, the attacker, the attacker is waiting with the Metasploit plugin, just, setting the remote IP address. Let me zoom on that, because it's hard, there are a lot of steps. So you set the remote host IP, and then you just, let's check it's the right one. So, yeah, it's the right one, 4.1, okay? So, we just load this resource, which is the resource file with the Auto-Pwn module. And what we are going to see is the module will brute force the log file, the name of the log file, because it is rotated every time the vCenter restarts. So we brute force the name, we find the log file, the last log file, we go through the log file, we parse it, we get the sub-session ID, we get the latest one, but you can get any one, and we create a session writer. So what the attacker has to do now is get to the desktop, this is the attacker, I blocked the attacker, and configure the proxy, configure the client to connect to the proxy, and just use my very elite username, which is bypass me, that's the core part. If you don't do that, it won't work. And not really, they're not kidding, that's hard-coded, because I'm a lead coder. And we get the certificate warning, so we can get poisoned as well. On the other side, we can see that the Auto-Pwn module is doing its stuff. If you see there is a moment where the session ID changes, that's where you actually perform the fake login and start sending to the server a fake session ID to write the session. And on the other side, the client starts loading the stuff. This is just a fake user. You don't need to have a valid user. And discover the plugins, load the forms, and all this stuff. And we are in as the administrator. Okay? Lindo, eh? But now the point is that you will get disconnected, okay, as soon as the administrator logs out. But you have to be quick, or you can script a module which does everything in automatic, like adding the user or stuff, or wait for me to release that at the end of the year. So that's more or less what you can do with the Auto-Pwn module. The interesting part of it, from a pentesting perspective at least, is that VMware did not release a patch for that. So there is no double-click patch. You have to go to a knowledge base article and download an upgrade procedure script which will upgrade your Jetty server until the next official vSphere update, because then you have to do that again and again and again and again. So I think that we are more or less going to see this for the next 10 years. which is fine for me. I mean, I'm a pen tester, it's cool to have that. Okay, that's a little bit behind. So, that was the session writer stuff. However, it's not just that. There is more, because we are not taking care yet of the management interface. As you might have guessed, there is not just a BI client. As I told you before, you also have the web-based console. So, I think that the interface is very fun, because it's easy to break in through that. It's very complex interface, a very nice, actually, programming stuff. It's all Java-based. Of course, there will be cross-site scripting, there were cross-site scripting reported, but the vulnerability I want to tell you about is the URL forwarding vulnerability, which was disclosed, I think, more or less 6 or 7 months ago, something like that. So basically, this vulnerability, written in the advisory by VMware, is URL forwarding. I don't know about you, but when I read the URL forwarding, I think about the client being forwarded somewhere. So that's what I was expecting. Instead, my good friend Luca thought, now this vulnerability looks cool, so let's exploit that. He started coding an exploit, and what he discovered is that it's not an URL forwarding at all. It's using the web-based interface to perform arbitrary post requests on arbitrary host. So you can basically use it as a proxy. That sounds cool. So what we have in Vasto is a port scan. You can obviously just tweak it a little and use it as a proxy, because you can use arbitrary post requests. The interesting part is that the vCenter is bound to be on some very interesting networks, like internal networks or virtual machine-only networks. So you can use that to discover systems behind that or proxy to internal systems. Very quickly, let's see how it works. So it's yet another video, and this is the port scanner. What we are going to do, okay, is using the web access port scan to scan a remote VMware host and have the VMware host connect back to us. As you can see, the only parameters you have to deal with is the bounce host, which is the system you want to bounce on, and the remote host, which is systems which you want to port scan. So what we do is we configure the bounce host as a VMware server, so this is port 83333. This has been patched like 6 months ago, but I consistently see it around. So this is to show that our address is 20229. So we run netcat. Well, first we configure it as the remote host, so the host we want to port scan. Then we run a netcat on our local machine on port whatever, just to see that we are connecting back to our system. Okay, so let's check that the configuration is right. You see, bounce host is the remote VMware server. We just run the exploit, and here is the port scan running. Let's see on the other side, on the netcat, and you can see the remote VMware server connecting back to us. You see? So, we basically can use that system, the remote VMware host, as a proxy or port scan or whatever, okay, and get a nice report back. Okay, that was an exploit that we coded, and we found it really useful doing pen tests because it's quite easy to reach internal network. But the management system is not just that, because once you start to screw up things, it's very likely that you will screw up more. So if they don't really like SSL certificates, there is bound to be more in that field. In order to see that, and that's more or less the last thing that we are going to see, I have to tell you through this very nice diagram how the management actually works. So you have the client on one side, which connects through SSL to the vCenter. The vCenter will then connect through SSL, it's still so-called, so HTTPS, to the remote EXXI servers. Of course, that SSL stuff on the right can be attacked, and that's what we are going to do. It's interesting because of the way it works. So how do we perform an attack? Well, you have to be correctly placed. So either you are in that network, or you are in a virtual machine on that network. Or you have the ability to move the virtual machine in that network. So there are some scenarios. They're not that, they don't really happen that often, but they can be useful, and it happened to me at least 10 times during pen test. So let's see how you can attack this stuff. So you attack this stuff through a simple man in the middle, through the server and the ESX server. Once you do the man in the middle, the connection is broken because they cannot speak. You start stopping the packets. Once the connection is broken, the administrator has to enter the root password to connect the ESX server back. That's how it works. And once he enters the root password, he just gets the root password. Of course, he gets the usual warning, SSL warning, but we all know how it works. If you're Metasploit guru, maybe we can talk about man-in-the-middle in Metasploit because I couldn't really figure out how it works. As a final note, before we see the videos of this, in version 4 and 4.1 there is a slight difference. So version 4 will only accept certificate with the same common name. So if you're sniffing the connection from a server to a server whose name is, I don't know, Pippo or Pedro or whatever, you have to use the same common name. It's just a trick, but you have to take care of that, otherwise it won't work. So let's see a video of this. Let's see how you can actually sniff the root password on the back end. So this is the virtual center, and here is our attacker doing the ARP spoof dance. So we ARP spoof, we start to perform the ARP spoofing, and as we can see, when the administrator tries to do any kind of stuff, the connection goes down. So we just cut the connection, okay? So the administrator, some preparatory steps. We run a simple proxy between port 443 and port 8080. That's where BARP is running. I'm doing this through BARP, not through Metasploit, just because I couldn't figure out how to do that. So we will have BARP running. What happens? Okay, as you can see, BARP is running on the localhost and is redirecting all the requests to the actual server. So it's pure man-in-the-middle stuff. So the administrator reconnects. He gets a warning, okay, but take a look at the warning. I had a very ending license. The pop-up he gets, it just, the certificate is wrong, and he only has the close button. Yeah, go, whatever. I mean, I know that everyone is going to click the go on whatever button anyway, but maybe just provide me an abort button. So, he will, and that's it. We just, close, okay, now go. And of course, once he enters the root password, he will get a warning, another warning. Okay, see, I can't control the thumbprint and all this stuff, whatever. And he gets a yes/no button. So, okay, you can easily imagine that if the administrator clicks twice, okay, I don't care, I deserve to get this password because he's stupid. So, that's more or less how it is. So, we get some basic transmissions, some packets going through, and we end up with the password, okay? Username, password, people, whatever, okay? You can see that password. Okay, and you can see, yeah, sure, but there are two pop-ups, not one, two pop-ups. The administrator has to be stupid. Okay, but let me show you the standard behavior. I mean, like, if there is no one in the middle. Because that's fine. So, the default behavior, without any man-in-the-middle stuff. So, what we are going to do is we are going to, stop the ARP poisoning. Okay, that's the ARP poisoning. We stop the ARP poisoning. Just in case we stop at BARP and all this stuff, we do a ping just to make sure that everything works. So, okay, no more man in the middle. Okay? So the administrator now can safely connect to the remote host. He gets the pop-up. What? Because no one is using trusted certificates. And then, once again, he puts the root password on, and same pop-up, once again. The point is that administrators are already connected to that server, so that certificate should be trusted. That's how it used to be in the old versions. It's not like that anymore. So it's basically really difficult, if you're not using trusted certificate, and no one is, to detect this kind of attacks, which makes them particularly nasty. Okay, so that's yet another way that you can attack VMware. Now let's quickly go through a couple of other options which are interesting enough if you're a pen tester. Because from time to time, it doesn't really matter how hard you are trying, you won't be able to break in. So, what do you do if everything else fails? You don't shoot yourself, of course, but what you do is you brute force. So we do have a brute force module in Vasto, which you can use to brute force the VMware systems. You can use standard Metasploit brute forcing measures. The interesting part is that you can brute force the local administrator account, which by default has got no lockout, so just brute force, or the root account, which itself has got no lockout unless there is some voodoo configuration involved. So you will be able to brute force all this stuff. So a lot of brute forcing stuff. To finish, there is something different in the local machine. All of this stuff has been done through attacking the infrastructure. But there is yet another attack on local system which does not involve any CPU or memory voodoo. Because I don't really understand this stuff. There are great researchers doing that, David Sormandy and all these guys. They're very good at doing this stuff. However, I go for simpler stuff. And the simpler stuff is the difference between virtual machines and hardware machines. Because once you start installing VMware tools on the virtual machines, you end up with a new attack surface, okay? A new boundary which can be attacked. There is a lot of research to be done there. I'm sure that people better than me will surely take a lot of findings on this field. But for now, I just want to show you a very easy finding I managed to get, just to show you that it is possible. This is an exploit in the SFCB server, the VMware interface, which is running on some VMware product, like the virtual appliances or the backup systems. Basically, it requires either authentication, so you have to be a valid user, or you have to be local to that machine. And remember the URL forwarding vulnerability? Combine that. So, it's an interesting vulnerability. It is basically code execution as root, because we like that stuff, and it is very trivial attack, actually. This is the attack. The service, the SFCB, accepts XML encoded files, so you can just send this XML encoded file and get some answer. It's just a basic HTTP shim stuff. What we do is we add an interesting column, can you see that, after the 121 in the hostname? And then we attach our payload. We cannot use white spaces, so it's a little bit encoded, but you basically do shell escape and execute code. Okay, this is a very rough finding, not very refined, but it shows you that you can actually break a lot of stuff just by looking at the local services. So there is a lot of fun to be had there as well. Okay, so finally, the question I was trying to answer when I started this talk, and which I hope you can answer now, is can we attack virtualization itself, not just side-by attacks or CPU-based attacks? And I hope that by now your answer to this question is yes, we can. Okay? So, summing up, you can sniff the administrator password or even execute code in its own computer. You can attack the hypervisor itself by path traversal. You can write other user session. You can attack the administration web interface using that as a proxy or stealing information from the local machine. You can even attack supporting services running on a local virtual machine. So there is a lot to do there. So yes, we have a problem. Virtualization today, the infrastructure is an opportunity. A very interesting opportunity to take as pen tester. So please, the next time you meet that VMware server, don't just run your standard vulnerability assessment tool, download Vasto and try it. I guess this is the right moment for questions, but maybe later in another room. So it's thank you time, thank you for listening, thank you for being here. I don't know if we have actually time for questions, but I suppose we are not, we don't.
One question.
If there is one question, actually. I know you're thinking that, so I am an Inter Milan supporter, okay?
Claudia, how much of this do you see open on the internet?
Sorry, I didn't get it.
How much of this do you see open on the internet?
Actually a lot. You see a lot of, so the question was how many servers can you actually attack once you get home? And there are really a lot of servers this open on the internet. Like in Italy at least, we do have at least 3 different service providers where you can actually buy virtual machines from, and you manage the virtual machines through the BI client. So they are opening their interface directly. VMware is doing a very good job on this, saying that there should be no way you expose the management interface, but everyone is doing that anyway. So yeah, if you just drop by a showdown, you will be able to act a ton of service. Okay, I guess that was the one question. So once again, thank you.